So we have worked with functions several different times and in this class. This is some more work with functions, except we're going to have radicals with this now. So we're going to evaluate some functions that are radical functions given this information. So on the first one, we're going to substitute a 0. And that's going to be 2 times 0 plus 3. And 0 plus 3 is 3. So when we simplify that, we get the square root of 3, and we leave it that way. We don't need to have the decimal or anything on there. The next one is the g function, which is a cube root. So g of negative 19 be the cube root of negative 19 minus 8, which is the cube root of negative 27. Cube root of negative 27 is negative 3. Next, we're finding g of 1. So in the g function, we will substitute a 1. So that would be 1 minus 8. 1 minus 8 is negative 7, so it's the cube root of negative 7. And then last one is f of negative 1. That would be 2 times negative 1 plus 3. Negative 2 plus 3 equals square root of 1. The square root of 1 is 1. Okay, and some more function work here. So notice it says to identify the domain and then graph each function. We can actually identify the domain based on what's under the radical on this. We can also go ahead and graph it to figure that out, but let's just talk about the domain here. So if we put in, remember, domain's about what values of x can we use for this particular function. If we put in a negative number, what happens? Well, that's not a real number, which means it's not in the domain, because the domain is about real numbers. So when you're looking at this, let's say we put in a negative 2, then we're trying to take the square root of a negative 2, which is not possible. So this domain starts at 0. Let me write this out. And the domain then would be from 0. So I was trying to write domain and it kept disappearing on me there. So this domain starts at 0 and it will go to infinity. So basically we're saying 0 and positive numbers are in this domain and negative numbers are not. And since our domain starts at 0, then we can just use ordered pairs to graph this. You can also use the fact that this is going to it's going to shift downward by 2. We've talked about that before. Basically, we can find the square root of 0, 1, 4, and 9. And even 0, 1, and 4 would be enough. So if we take the square root of 0 and then subtract 2, we get negative 2. The square root of 1 minus 2 would be 1 minus 2, so negative 1. The square root of 4 minus 2, the square root of 4 is 2. 2 minus 2 is 0. The square root of 9 minus 2 would be 3 minus 2, which is 1. And so our graph will look like this. I'm going to have 0. I'm going to use a brighter color. 0, negative 2. 1, negative 1. 4, 0. And 9, 1. So this has some curve, but it's kind of a slow curve. It doesn't curve quickly. All right, and that's it for this one. And then on the last one, I gave you some choices so that you would come up with some nice numbers here to take the cube root of. But let's talk about the domain. So the domain in this case is negative infinity to positive infinity. Now, how do I know this? Well, there are no restrictions on the values I can use for x here, so all real numbers would be negative infinity to positive infinity. We could put negative numbers, positive numbers, 0. Any of those are okay because it's an odd root, so that makes this domain can be anything. Now, this one does have a curve to it for sure. If we substitute, right, we're going to have negative 1 plus 1. So the cube root of 0 is 0. 0 plus 1, the cube root of 1 is 1. Negative, I'm about to run out of space here. Let me scoot that. Negative 2 plus 1 is negative 1, and the cube root of negative 1 is negative 1. The cube root of 7 plus 1, that equals 8, and the cube root of 8 is 2. And then the cube root of negative 9 plus 1 is negative 8, and the cube root of negative 8 is negative 2. All right, so let's put this on the graph. My drawing on the graphs on this are a little wonky sometimes, but we have negative 1, 0, 0, 1, negative 2, negative 1, 7, 2, and negative 9, negative 2. Okay, I paused my video for a second because my dog was over licking his paw and making lots of noise, and I didn't want that on the video. And went ahead and drew this. This one continues on because in both directions, because remember, we don't have any restrictions on this domain. All right, so that's the end of the lesson.